Hi, in this video, we will go through how to approach a hypothesis test under the T procedure. A test of significance is a formal procedure that allows us to judge a claim or hypothesis using observed data. During this test, we compare two hypotheses. The first is the null hypothesis, H0, which is a conservative statement about the population mean, denoted as mu. The second is the alternative hypothesis, HA or H1, which proposes that the population mean is less than, greater than, or not equal to a specific value, denoted as mu0. There are many types of hypothesis testing. We perform hypothesis testing under the T procedure if 1. The data is an SRS of size n. 2. The population normal distribution assumption can be relaxed. If n less than 15, the data need to appear symmetric, single peak, with no outliers. If n is less than 40 but greater than or equal to 15, the data need to have no outlier nor strong skewness. If n is greater than or equal to 40, then there is no restriction on the data shape. 3. Both mean, mu, and standard deviation, sigma, are unknown. Since we do not know the population standard deviation, sigma, we estimate the standard deviation of mu hat using data. The estimate is called standard error, which is equal to the sample standard deviation divided by root n, the sample size. The sample standard deviation can be given in the question, or calculated from the formula given. Now, we standardize the value x bar to obtain the T statistics for testing null hypothesis, H0, mu equal to mu0, is the difference between the sample mean, x bar, and the population mean, mu0, divided by the standard deviation of the sample, s, divided by the square root of the sample size, n. The p-value is defined according to the alternative hypothesis. Given t is a random variable following the t distribution with degree of freedom equal to n1. If the alternative hypothesis HA, mu is larger than mu0, the p-value is the probability that t is greater than the t statistics. If the alternative hypothesis HA, mu is smaller than mu0, the p-value is the probability that t is smaller than the t statistics. If the alternative hypothesis HA, mu is not equal to mu0, which is a two-sided test, the p-value is 2 times the probability that t is larger than the absolute value of the t statistics. During exam, you may find this question. A new weight loss pill has been tested on 5 individuals, resulting in the following weight losses in pounds: 2, 3, 4, 5, 3. The question is whether this pill helps people lose weight, i.e., the average weight loss is greater than 0. Perform a hypothesis test with these data, assuming a normal population and unknown standard deviation. What conclusions can you draw from the test results? Step 0. Check the questions. It is a hypothesis test question, obviously. Then we first verify whether the question satisfies the T procedure. First, the data is an SRS of size n equals 5. When n less than 1.5, we require the data appear close to normal. Second, the population follows normal distribution, which is important as n is less than 15. Third, we do not know mean mu nor the population standard deviation sigma. Then, we can perform the one-sample t-test under the T procedure. Next, step 1, state the hypotheses. You should notice that you want to test whether weight loss is greater than 0. First, the null hypothesis is a conservative statement, so it is set to be H0, mu is equal to 0 pounds. As you want to test whether weight loss is greater than 0 pound, the alternative hypothesis is HA, mu is greater than 0 lb. As the teacher is so mean that he does not give you the sample standard deviation. However, you can always calculate it by yourself. Step 2. Calculate the sample standard deviation. Copy from the formula sheet. You have S equals the square root of the quantity n times the sum of xi squared minus the quantity sum of xi whole squared, all divided by the product of n and n minus 1. N is equal to 5. The sum of xi squared is 63. The sum of xi is 17. So, we have square root of 26 over 20. And the answer is 1.1402. Step 3. Calculate the t statistics. The t statistic equals the quantity x bar minus mu sub 0 divided by the quantity s divided by the square root of n. Here x bar is 17 over 5, which is 3.4. And the t statistics becomes 3.4 minus 0 divided by the quantity 1.1402 divided by the square root of 5, which is 6.6680. Step 4. Calculate the p-value. as the HA, mu is greater than 0 lb. The p-value is the probability that t is greater than 6.6680, where t follows t distribution with degree of freedom equals 4. Check the table C row number 4. You find the t statistics is between 5.598 and 7.173. So, the one-sided p-value is between 0.2% and 0.1%. And, in fact, if you use a calculator, you have the p-value to be 0.00131. Both methods allow you to answer the question. Let's put the table aside as we do not have enough space. Now, it is gone, and we do not need to use it again. Step 5. Compare p-value with. As the teacher is so lazy that he does not specify the significant level, alpha, you can assume it to be 0.05. Compare with the alpha, your p-value is smaller. Step 6. Make a conclusion based on the comparison in the question. As the p-value is less than the significant level, 5%, we can say there is strong evidence to reject. We accept the alternative hypothesis at a 5% level of significance. The weight loss pill looks effective. Holy moly, it is a magic pill. Once again, we can check our result using your calculator. First press Stat. Choose 1, Edit. Then enter the data 2, 3, 4, 5, 3 in list 1. Then press Stat. Tests to 2, t-test. Then choose Input as Data to mu0 as 0 to list as list 1. For alternative hypothesis, choose greater than mu0. Then press Calculate. You check. The t-value is, the standard deviation is, and the p-value is 0.00131, which is the same as our calculation. Magic! That finished your t-test. Phew, what a task! Since we use p-value in the hypothesis test, we once again repeat the definition of p-value. The p-value of the test is the probability, computed assuming the null hypothesis is true, that the test statistic would take a value as extreme as or more extreme than the one actually observed. Besides, although the pills look effective in the test, the experiment is not randomized controlled. Thus, we should accept the alternative hypothesis with a huge reservation. If you want to lose weight, it is better to do more exercise and eat healthier. Let's make students hate statistics less.